Okay, hello, my name is Lukas Daum. I'm software engineer at Perception Park, and today I will tell you something about our modular system for processing of hyperspectral data. To start off, our company is located here in the beautiful city of Graz, as you may have noticed already, and we are focused on hyperspectral imaging and especially data processing. So why did we choose to do that? Because if you work with hyperspectral data for the first time, your experience may look a little bit like this. Thank you. The problem is that hyperspectral data is way more complicated than traditional image data. That means you cannot easily see all the information that's contained. You need to scan relations between layers to find your information that you need. You also have more disturbing influences that you cannot see with the human eye, like humidity, for instance. And so we wanted to create a system that makes hyperspectral imaging as easy as possible to use. I have two examples that show what our system does. The first shows polymer sorting. You have on the left side an original image. It shows some plastic pieces of different colors. You can see the color, but you cannot see the material. On the right side, you can see the output of our system. And here you can see each material is assigned its own color. So now you can start sorting by material. The next example is from the pharmaceutical industry. Again, on the left side, you see the original image of 3 blister packs that may or may not contain some products. On the right side, again, the output of our system, and here you can see with hyperspectral imaging, you can at least partially ignore the blister packs and focus on the products themselves. So you can detect missing objects, you can detect broken products, or even wrong products, because as you can see, you can also see the active component within those pills. So why did we choose to go for a modular approach on our system? That's also quite easy to answer, because if you create applications for the industry, usually many different parties are involved in that process. You have camera manufacturers, you have chemometry engineers, application engineers, system integrators, and also a lot of software tools are used in that process. We want our software to be a platform for all those parties, so everyone can focus on their core competences and don't need to worry about everything else. Also, a modular approach makes it very easy to reuse parts that were created once. So how does our system work? We are building so-called processing networks. They basically consist of many processing modules. The set of modules that can be used can be extended by our plugin interface, so third parties can develop plugins for our system. And there are 3 archetypes of these modules. You have data receivers, which are the source of data, like cameras or files from hard disk, for instance. Then you have processing blocks, which do the actual processing, things like projection from high-dimensional hyperspectral space into, let's say, 3-dimensional RGB space, for instance. And then finally you have the data transmitter modules, which are the actual output of our system, something like a camera link or GigE-Vision, for instance. Here's an example of a very simple processing network, basically just a sequence of modules. Starting with the receiver, ending with the transmitter on the right side, the blue squares here. And you can see there are 3 different pools where you can take your modules from. The first one are factory modules. That are those which we provide to our customers by default. Then we have third-party modules. That are those modules that are added to the system by the plugin interface, so by third-party developers. Then we have module groups, and the group consists of sub-modules or even sub-networks themselves. So that's a very good way to hide complexity from the customer, and you can go even further and create custom user interfaces for those groups. And as you add more components or more modules to your networks, they get more complicated. And to reduce complexity, we chose to go for a workflow-driven user interface in our software. That means we divided the whole process of creating an application into steps. And in each step, the user only sees what he needs to do in this step. Here, the image shows one step of the sequence. Here, the user can choose the model to apply on the hyperspectral data to get a colorful image out of it. And behind that, what you see in the red rectangle here, there lies a more complicated processing network, but the user only has a few buttons to press, basically just choosing the colors you want to assign to chemical materials. Now, let's assume you have done all that, you have your processing networks for your application, you're satisfied with that, and now you want to have it ready for the industry. For that purpose, we have our perception system. That's a separate hardware unit with hardware acceleration, for instance, GPU acceleration. And you can simply compile all your networks for your application, send that to the system, and this will then run the job. And it's also a scalable hardware. That means more powerful hardware means faster processing if you need it. This slide shows how the perception system is integrated into a bigger machine. You have your hyperspectral camera linked to the perception system. The camera sends the original hyperspectral data, and then you have all the processing done on the system, which then sends one or multiple monochrome or RGB streams to a target machine. And this means you don't need to change that much to use hyperspectral imaging, because you can just use it as a normal camera. And at the end, I also want to mention some further extension points of our so-called hyperspectral operating environment. You can not only add more processing function, you can also add more hardware units to be used with the system. You can add user interfaces, so if your customer needs special user interfaces for any purpose, you can just create a plugin and add that to the system. Then you can also add new file importers or exporters, so you can still use your favorite software and just share the data between our software and the other software. And then we have also valued data. That means you can have plugins that contain content like calibration information and reference data for your processing. And it's very important to mention that all of these plugins are guarded by a license key by default, so you don't need to worry about licensing on your own. Okay, that was pretty quick. Thank you for your attention. I hope you'll enjoy the conference here in Graz. Sorry. Thank you.